All right. Good morning, everyone. Welcome to the session. Let's talk about best practices for end-to-end digital experience monitoring. My name is Imay Kumar Jagannathan. I lead a team of specialist solution architects that focus on cloud operations, including observability.
Hey everyone, my name is Bobby Hallahan, and I'm a solution architect here at AWS. So in today's agenda, remember this is like a 300-level session, and we're doing best practices. But we're going to do a few minutes on overview, right? So like why monitoring is important, what we mean by digital experience monitoring. We'll get like a definition out of the way, so we're all kind of on a shared playing field there. And then we're going to go into some best practices. So that's going to be like a lot of this session. We're going to do a lot of different best practices. We have quite a lot of content today, so we're going to just dive right in.
All right, so we're going to do back and forth, as you've already seen. So we're both on the stage, something new, so hope it all works out, right? So help us out here. So feel free to raise your hand if you've been in this situation. So some of you here are developers. I see someone there, DevOps engineers, architects, infrastructure. Well, when things go wrong and you have to meet your customer, it's really challenging, right? So I've been there. When I was a developer, I vividly remember the customer was internal, and they were standing right next to me at my desk, and they were watching what I was doing, and like, when are you going to push this change, right? Just the thought of going through that alone gives me shivers. I don't want to do that. But at the same time, from the customer's point of view, I don't like looking at a broken website either. So when I'm using something, I just want it to work, right? It's really challenging to live with that kind of a situation. Bobby, you've been at TAM before.
Yeah, so earlier in my career at AWS, I was a technical account manager. Anyone here on enterprise support have SAMs? Yeah, a few? Okay. So when those business critical severity cases come in and you get paged, sometimes it's something that, as a TAM, you don't have direct control of what you can do, and your customer can be like really frustrated, obviously because business critical systems are down or impaired, and it can be a frustrating experience, and it's not one that you necessarily want to be in, and it's one reason why I decided to specialize in observability a while ago, because I know that's something we can do to be proactive about helping our customers out.
Right, so obviously we all understand monitoring is important, right? That's why we're here. We're going to talk about it. Well, so unsurprisingly, it turns out that outages actually cost organizations a lot. And yes, there is the short-term impact is the monitoring impact, but the long-term impact, in my opinion, is the goodwill and the trust that we lose with customers, right? When there are slow and sluggish websites, customers don't trust those websites anymore, and they kind of like bounce out and maybe look somewhere else, right? And a recent study actually shows that over 2/3 of outages actually cost $100,000 each, right? And this cost is actually going up. It's on the rise. And that is because of us more and more relying on for core use cases on digital services and like banking and flight booking and all that stuff and so on. And because of that, the SLAs are on the rise, and the regulatory bodies are stepping in when the core services go down, and that actually adds to the cost to the organization when outages happen.
Yeah, so with that, like we said, let's get some definitions out of the way. And what we think of is digital experience. So what do we think of when we say digital experience, right? And how we have it here is user interaction on a digital property such as websites, mobile apps, APIs, chat, social media channels, etc. Meaning, really simply put, any interaction you have on a digital platform, right? Typically, you think of a website, but there are other and various ways of digital experience. So now with that said, what do we mean by end-to-end digital experience monitoring? Because typically we like to think of, all right, it's APM, it's RUM, it's synthetics, right? It's that front-end experience, right? Something that you don't necessarily get from server monitoring. But we also want to think about think of that end-to-end piece, right? So it's a comprehensive approach to tracking, analyzing, and optimizing end user experience with digital services and applications, right? So it's fairly straightforward, but the one thing we want to key in on is end-to-end, right? So we're going to look at the entire stack here.
Right, so let's take a look at the typical user request flow. It's nothing extraordinary here. We know there's a website, there's a browser that the user is using, and the requests go over the network, internet, and then it comes to your network. There's a load balancer, there's a web server that serves the requests, and there are multiple APIs that, if it's microservice, it's even more complex. It goes to multiple such locations, and then eventually a database maybe, and so on. So when you add all of these different layers, it actually gets much more complex, right? So what are the complexities we're talking about? Where because of these multiple layers involved and the fact that when microservices come into play, there's polyglot situations and all of that, it really opens up to multi-point failures, right? And because there are lots of parties involved here, there is lack of single-threaded ownership, so you get less visibility, less overall visibility, and you have less control over the environment because sometimes you're actually making use of a third-party solution, or maybe you're completely dependent on your API's response time on some other API that you don't own, and that actually sets, and also there is varying performance expectations and so on, which actually makes it much more complex.
Yeah. So, like, we know this is important, right? And if it's important, like, why hasn't everybody done it, and why isn't it perfect for everybody? And obviously, because there's some challenges to this. And if we want to think about applications or things we supported, maybe 4 or 5 years ago, odds are those applications or services could have been, a little bit more simple. Even in some cases, you'll see these monolithic applications today. Actually, in many cases, we still see them. But then if you move to like service-oriented architectures and then even microservice architectures, you're looking at things where you have, many different downstream dependencies that can change relatively rapidly. You have deployment frequencies that are much faster. You have different teams that are responsible for things, so it's not just, that's the other microservice, we'll just chuck it down the road, right? And what I like to think about in this case is, like, if you fundamentally re-architect your application from the ground up to be like a microservice distributed application, like, you need to fundamentally rethink how you do observability. And with that being said, Maya, like, what do you think our customers need in this case?
Well, yeah, so first of all, customers are the center of any business, right? So when we were preparing for this session, I got reminded of this interview that Jeff Bezos gave quite a few years ago. And this was a very different point of view, where he talks about all those things that do not change over a long period of time, right? So we always think about, like, what are those things that is changing, what is next, and let's go address that. But his point of view is that I'm focusing on things that don't change for a long period of time. Well, no one is going to walk up to like Jeff Bezos, as he says here, and saying that, hey, I wish you sold, your prices were a little bit higher than others. Or no one is going to say that, hey, I wish you deliver a little more slowly. So I was thinking, okay, what are those things that don't change over a long period of time for observability use cases? These are things that never change. I meet hundreds of customers every year overall in my team. So we meet like thousands of customers every single year, one-to-one. And I'm yet to meet a customer who came and told me that I would like to use CloudWatch or other services a lot more. I want to spend a lot more time on it, and I want to be spending a lot of time debugging and finding root cause. No one has said that to me. And everybody wants to use a service that helps them to reduce their mean time to resolution at a lower cost, and that is easier to use and configure, and also scales and adapts to their changing needs all the time, right? Bobby, having given this, whose responsibility is for customers to get to this situation?
Yeah, so thanks for bringing that up. And like with many AWS services, like, we're all familiar with the shared responsibility model. And depending on services, that kind of changes, right? You look at like Lambda or maybe like RDS or EC2, that changes just kind of depending on the service, right? The level of like how much that management AWS is taking on as opposed to how much we're giving you as the customer. So you can think of it as a similar concept with observability, right? So from an observability standpoint, we're giving you, our APIs, SDKs, easy-to-use interfaces, but generally speaking, right, it's those data store layers, right, and log, metric, and trace data, as well as the ability to get and fetch that data as well, or put and fetch. So querying capabilities and all of that. Now, from a customer standpoint, what are you responsible for? This is where it comes down to selection of signals, automation, signal enrichment, what to alarm on, and instrumentation, essentially. Now, we do want to give you proactive guidance, prescriptive guidance, curated experiences for this, but at the end of the day, you know your application best, and that's when it comes down to, you need to decide what to alarm on. And in this session, we're going to get into a few of these best practices about what it takes to alarm on things and what signals we need to select.
Right. It's basically a partnership, right? But at the same time, you also always have to try to shift left and try to focus on how you can optimize the input itself. That's what we're going to focus on here. We're going to talk about how you can make decisions on what signals to even select. Like I said, I talked to hundreds of customers, and the customers that I have spoken to are those that are intentional in terms of selecting as to what to monitor and how to monitor, are the ones that are very successful. They have lower cost of operations, and they seem to be able to find issues quickly because they are dealing with less noise and more signal. All right, so let's look at a kind of a workflow, right? Just kind of a guidance in terms of best practices. First, we suggest that you start with the business SLAs. Talk to the business and actually find out what is that they want in terms of SLAs that you want to that whatever you're building want to adhere to, right? You start with that, and it actually helps you understand why you're building, or kind of nail into like why are you even writing an application or a microservice, and then you kind of move on from there. So let's look at an example of how that could look like. So let's say there's an API, and you want to make sure that the SLA is clear here. And we are talking about, okay, this API should have a 200 millisecond response for 99% of the requests, right? That's a very clear and specific input. Now you take that, and now what do you do with it? Now you move on and find out SLOs, was service level objectives. Based on, the key thing is here, based on realistic technical abilities. How do you know what, there's a button there that mutes it, sorry. So there's a, how do you know what your realistic technical abilities? At the beginning, when you start working on it, it may be hard. So we suggest that you go with industry standard. But you will notice that as we move through in this process, you will know that you can get more accurate and more predictable in this process, right? So let's see an example for this. Okay, in this API, we found that there is a database dependency. Now, okay, so the database, we expect 97% of the database requests to be under 100 milliseconds, and 99.5% of API responses to be under 200 milliseconds. You can see that we are already a bit more aggressive than the SLAs. This is for us to have some room to fail, because we want to be able to have some wiggle room, because you cannot build something that does not fail all the time. We all know that everything fails all the time. So we want to make sure that we set higher expectations so there's wiggle room to fail, and we can track.
So next we need to look at identifying appropriate SLIs to track the SLO, right? So like that service level indicator, and this is the actual like signal selection we want to speak to. And in the practical example, we want to think of so percentage of API requests completed within 200 milliseconds. So you have things maybe like percentile rank that can give you something like that. If we're thinking of like metric math, which is like super underrated. So check out metric math if you haven't done so already. But this, that source can be from like an application APM tool, measurement frequency. We want to do that continuously, hourly. And then from a database standpoint, we want to think of percentage of database queries completed within 100 milliseconds. Of course, that can come from any database monitoring tool, right? So we're thinking of like, this is the metric we want to look at. But then you say, right, now we have, an SLI, and hey, it's easy to do it for 2 signals, right? Maybe for even 1 application, right? We'll work with customers all the time. It's like, hey, you know what? That's not necessarily the challenge. The challenge for me is maybe I'm in like a platform engineering team, and I don't have to do this not once, but maybe hundreds of times with many different teams operating in different environments, different accounts, different types of workloads, like different database engines, and that's where like it gets like pretty difficult. And a best practice why we wanted to include that here is number 4 and 5, right? Which is set consistent instrumentation standards and then standardized collection agent configs. So in consistent instrumentation standards, what we mean by that is having these ready-to-go instrumentation standards. So this is like signal enrichment, how you're collecting, and then enabling these other application teams to better and more effectively collect and instrument their apps. And then you as, let's say maybe a central observability group would then be able to dictate what gets there, and then you're enabling people to do it instead of dictating it to them, like, hey, we need these signals, and versus, hey, we're going to provide you these agent configs and easy ways to get instrumented. And that's time and time again, we've seen customers be successful with that. Same goes with standardized agent configs. Now, the next one we want to think of is setting SLO budgets and tracking mechanisms. So when we think of budgets, we want to think of like error rates or burn rates, right? You have an error budget, so the number of requests that can fail before we breach. And this is where it's another big best practice we're going to key in on, right? But it's not just the SLO. You want to look at burn rates, right? And that shows how fast you're going to until you breach your SLO. And using something like that, you can then alarm on the burn rate, knowing you can proactively try to catch something before your SLO breaches. So you don't necessarily have to wait until you're in, I guess we'll call it non-compliance or an alarm state. We can look at something that would be a precursor to say, hey, if this request rate continues at this period and this error rate continues at this, we will breach our SLO in the next, 20 minutes or something like that.
Right, so that would be SLI thresholds, like setting that up and tracking that and getting alert based on where you are with it. Okay, let's see an example, right? So here in this API that we're talking about, let's assume there are 5 million API requests per month. If you have 0.5% of wiggle room there, so it basically means there are 25,000 requests that can actually breach the agreed upon SLA, right? So you track that for that period, and you set up SLI threshold alarms and burn rate alarms on burn rate. So you're aware of, okay, what is the current budget that you have already burnt, and how much more time is there for you in the month to operate. And if you continue to exceed on that, if you continue to fail on that, that basically means that you're having some kind of an issue, right? So that you will actually discuss that in your COE sessions or correction of error meetings that you conduct after every incident you sit and discuss. So SLOs and your all this input, all this data should be included in those discussions. We strongly recommend that. And like I mentioned before, in step number 2, I talked about like setting realistic SLOs based on realistic technical abilities. At this point, if you see that you're violating violating more often than you desire, that means that something has to give. So you either go talk to the business team and get more lenient on the SLAs, or maybe work on improving their technical architecture to be in compliant with the SLAs that you agree upon, right? It's a learning and iteration process. You keep doing that over and over, and then you get better at it. And with step number 2, over a period of time, gets more predictable and accurate, so you can operate in a much more consistent and consistent manner.
So now let's dig into like typical request flows. And where we're going to start here is right at the start, right at the browser. Like I said, if we think of like typical digital experience, right, it could be a browser, a mobile app. In this case, we're going to start with our browser. And we want to think of like, all right, so like what can go wrong here? Obviously, a lot of things if we've used browsers before. You interacted with digital applications. We've all seen performance problems. I think we can all think of one. But to help illustrate it, we did put together a very short presentation demo of a flower shop. And in this case, what we're going to do is we're going to try to log in to our site, and we're going to see what happens. And now that we've logged in, we can now see that there's, it's taken a bit to load the images. Some of the buttons aren't even loading. Some of the images aren't loading. Obviously, there's some problems here. And in some cases, these problems may not be something you would catch from server-side instrumentation. And what we want to think of, and at least how we've kind of categorized this, is like it kind of comes into 2 different flavors, right? There's things that are performance impact, right? Page performance, just the thing, it's loading slow. It could be a networking thing. Could be maybe my content's too big. Static content, so assets like CSS. If anyone's ever seen like a CSS asset fail to load and the whole site just looks horrible, that can be something. Or even like JavaScript errors. That can cause just things not to function correctly on your site. So like these are just a few, not everything, but a couple just to give you the idea of like there are performance problems. However, digital experience isn't just getting things to work really fast. We also want to think of user experience challenges. So one I think gets overlooked a lot is interface, right? And we want to think of interface of odds are you have a digital experience or a digital platform because you want your users to interact and do something with it, right? So let's say if it's maybe for like class registration, I want somebody to go in and sign up for a class and be able to register. Or if it's for a bank, I want somebody to go in and log in and do something. Or if you are an e-commerce site, I want somebody to be able to log in, select a product, and check out. Now, if the interface is horrible and your user gets lost and they can't do those things, that's obviously something you want to be able to track. Same thing that are like device specific, right? If the layouts and nothing works on different types of devices, that's something to look into. And then, of course, accessibility. I think it's almost criminally understated how important accessibility is. There's a vast number of people in this world that use screen readers and need some sort of assistance interacting with digital platforms. Taking the extra time to make sure your content is accessible is something that I don't want to understate that. It's really important. So now, what metrics do we want to look at? And here are a couple of key ones, like we want to talk about web core vitals. So we have 2.5 seconds for largest contentful paint, 200 milliseconds for next interaction to next paint, or INP, and then cumulative layout shift of 0.1. These are those kind of benchmarks you want to track. So if you're looking at front-end digital experience, you want to have something that can track these web core vitals, and it's something you want to be able to measure on. Now, in terms of other metrics we want to take a look at, right? We have things like navigation frustrated, satisfied, and tolerated transactions, HTTP status code counts, and then JavaScript error counts. So these are actual metrics that you would be able to use to then be able to evaluate the performance, overall performance of your site. So with that being said, what tools do we have available within the CloudWatch services, right? And this gives us first CloudWatch RUM, or real user monitoring, and then CloudWatch synthetics. And Amaya is going to walk us through a little bit of CloudWatch RUM and how it works and give us some best practices.
Right, so CloudWatch RUM is pretty straightforward. So you go create something called RUM application, and then it gives you a bunch of JavaScript that you can just plug into your websites, right? So the moment you plug that in, RUM actually collects different kinds of information. The first, starting with the navigation events. So that tracks how your user journey is in your website, like what pages are they visiting, and what pages, not only what pages are visiting, but also their navigation path, and how they're getting to their, let's say, your checkout page. Are they bouncing off of a page that you actually want them to spend more time on? All that information gives you lots of insights into your product managers, to UX designers, to design better experiences for your customers, right? Then comes the JavaScript and HTTP errors. That is, in the demo that you saw, there's one of the images that failed to load. And that HTTP error, or if it was a JavaScript error, that would have been caught in CloudWatch RUM if that was enabled. And you have client-side performance metrics. Again, in the same demo that we saw, there were a couple of buttons that it took a while for the buttons to load. That basically means the page was not ready for the user to interact. That is, the DOM, the HTML DOM, was not ready for the browser to allow the user to interact. So that is a problem. So you want your websites to be quick, load fast, and be available immediately for the users to interact. So once you enable, CloudWatch RUM collects all this information, sends to CloudWatch, and there's a nice interface where you can go take a look at your user navigation. You can understand how users are using your website, do all the RUM-specific things within CloudWatch in one interface, right? But this data is also available in CloudWatch metrics and CloudWatch logs. So you can actually go create alerts. Maybe you have SLOs for this. You can set SLOs for these things. You can set alerts on that. And you can obviously query CloudWatch logs insights using logs insights querying mechanisms. You can even set anomaly detection for CloudWatch metrics and find out if there are any anomalous situations that are causing some issues. And also, we strongly suggest that you also use this feature called metric filters. So if there is a metric that is not available for you out of the box, then you can actually use the CloudWatch logs metric filter feature to extract new metrics and under whatever dimension you desire, and use that for whatever purpose that you're trying to solve for. What are the best practices in using CloudWatch RUM? Starting with use realistic sampling setting. What do we mean by that? So by default, CloudWatch RUM actually samples user requests, right? That is to save on costs, and also at the same time, try not to give you too much information or make it very noisy. You can increase that if you want to, but remember that is going to add on cost and probably more information that you have to process, right? It could be useful in some situations, maybe not in some situations. Include X-ray traces. When you include X-ray traces for every page event or user interaction that is captured, the X-ray trace ID is associated with it. That means it is not only the user's request and path that you can see, but you can also see which particular user, which particular request came to that page and what other services that were impacted. So you're not only seeing the web front-end part of it, but also seeing all the different services interactions that this website is making to other systems that you have, which is quite useful for troubleshooting. Enabling cookies. There are two types of cookies, session and user cookies. When you enable them, you get the session ID and the user ID, so you're able to track how many users are tracking and who are they, and are they revisiting your website often and so on. For that kind of information is really important. Finally, this is not an all or nothing scenario. So you can actually pick and choose the telemetry that you want. Let's say you're working on your website is a spa application or a single page application. Page navigation may not be the most important that you want to know at that point, right? So, but DOM, how quickly a DOM is ready for the users to interact, might be more important. So at that point, you can actually pick and choose. Maybe you can just ignore the page navigation events, and you can only pick the JavaScript errors and the client-side performance things. So it allows you to pick and choose whatever you want. So we strongly recommend customers to leverage these features. And we also put together a QR code there that you can scan if you want to, a sample reference GitHub repo that you can take a look at for more specific details.
Thanks, Amaya. So go back one. Okay, Yeah, so we're going to talk about CloudWatch Synthetics. So sometimes RUM, right, works great, right? We have real users, we have high traffic, and we know what they're doing, right? It helps us understand user flows, but in some cases, I want to vet out that a given API or workflow works, or maybe I want to make sure that on certain devices, device types, we can do that. And that's what synthetics can be really valuable for, right? We're doing synthetic testing. And essentially how this works is it is using Lambda with a Puppeteer or Selenium layer. So what synthetics does is orchestrating those Lambda function executions for you, using Puppeteer or Selenium to then, sets up a headless Chrome browser, makes requests, and then we'll send back that data through CloudWatch metrics, as well as take things like screenshots of that session, and as well as capture an HTTP archive file or the heart file. From there, it sends data to CloudWatch logs. Like I already said, it can go to metrics, which then you can alarm on. The metrics can then be based on not just the overall invocation of the synthetic canary, but then each subsequent step. So when we think about best practices for synthetics, the first one is probably the most important, right? Don't use it as a health check. If you want to do a health check and you just want to get, does it give me a HTTP 200? Does the TLS handshake work? Use Route 53 health checks. It does it from like 8 different places, multiple times a minute, and it's cheaper. What Route 53 health checks can't do, or as far as I know they can't do, is do things like actually log in as a user and then do some sort of specific workflow. They're not going to load up all of the static assets and give you all of those all that header information that you can then save. You want to think of synthetics as, it's much more powerful than just a health check. And while you can do it as that, I would strongly advise, take a look at Route 53. If you're just looking for health checks, do that. Leverage groups in synthetics. So you can create these synthetic canaries within groups to help you organize and then do things in, maybe across different application sets or within, multiple step phases. I say use it with several steps. I mentioned that a couple times. And what I mean by that is not just go to the website, but then go to the website, log in, add a product to a cart, check out, single workflow. Or maybe I want to have several steps where you can have, like I've seen customers add hundreds of steps in their canaries. So based on how synthetics is priced, right, it's per canary execution. So there's some creative ways in which you can be pretty cost effective by leveraging multiple steps. Next one, use Secrets Manager. I said being able to log in. Since this is Lambda, you have the power of all things Lambda does, including other AWS APIs. A really popular one is Secrets Manager because then I don't need to store sample user credential secrets directly in my Lambda function. I can just have that in Secrets Manager. Lambda can then call that very easily and then use it. And then, of course, if you're not like hands-on with like Puppeteer and Selenium, look to use something like Blueprints. We have plenty of Blueprints to help you get started, and it's a really easy way to pick up and get going. Now, if we want to take a look at like that next layer, right? So we took a look at our browser, and now we want to think of, and how we have it classified here is internet. What happens between the browser and our first endpoint. And we also want to think like where in the network. So we are looking at the internet, but we're going to look at just various places in the network of things that can cause performance problems, right? So we have just overall internet, application connectivity, and then kind of generalized a bunch of stuff like, okay, within your VPC. And I guess I'll start with like wouldn't it be great if I had like a map that would show me internet health issues, and if those issues were impacting my users in a specific way? Well, the good news is this exists with CloudWatch Internet Monitor. Oops. Yeah, CloudWatch Internet Monitor. So this will give you a map showing any open and existing ongoing internet issues for like internet weather. But since we also, you're able to use Internet Monitor with your, let's say like CloudFront logs or VPC flow logs, for example, you're able to then take in, and we can then tell you, is your application actually impacted, or are your end users impacted by these specific events? So for example, we'll give you things like health event timelines, or being able to determine, reduce latency in given regions. So we're able to see where most of your traffic is coming from, and then even suggest a more optimal region, or look to suggest something like CloudFront and Global Accelerator. On top of that, it can give us things like traffic overview, so availability, performance scores, and then most importantly, and I think this one will probably resonate with the crowd that cares about digital experience, is traffic by city or destination. So now you know exactly what cities your user requests are coming from. So it can get very granular in that regard. So now outside of just like internet monitoring, we want to think of like within our application. And just a couple days ago, we launched a new feature called CloudWatch Network Monitoring or Network Flow Monitor. So this provides us granular insights to the network performance of our AWS workloads. This is an eBPF agent that you can install on your workloads, but that in conjunction with additional telemetry we're providing from the service is going to help us accelerate troubleshooting by sending health events to AWS support, and then give us a more proactive approach to monitoring network health. And I think if we dig a little bit deeper into this, right, while we have monitor network workloads, assess network-driven impact, so we understand latency and loss on our given network, but this last one, I think this one might resonate with you all, which is identify impact from AWS. So who's ever been in this position where something is happening and it's like, do we know if it's AWS or do we know if it's us? Does that ever happen? Yeah? Okay. Customers get this a lot, and this is built to help us understand where that network impact is and what the source of that degradation could be. So how this works is, essentially, we mentioned we have managed agents collect workload metrics, network and compute. It's a passive monitor using eBPF, and it's doing TCP inspection. On top of that, from the AWS network infrastructure, we're collecting additional metrics for you, and then we're building those in a correlated way, and then you can view that through CloudWatch metrics. So what I think is really exciting here is that I don't think we've ever before had like an eBPF agent collection for telemetry. So that on its own right, I think is really cool. But outside of this new feature, we want to think of like other VPC telemetry sources. And this is what gives us things that I think would be important within your VPC to look at. So you have traffic monitoring, mirroring, reachability analyzer, other CloudWatch metrics, and VPC flow logs. And the reason why I bring this up is like before we get to a best practice, right, we need to look at like what signals do we have that are available. And you want to think of this really from anything. If it's not just network, any type of application or anything you're monitoring or looking at, you want to think of what signals do I have available, and then like do those actually meet my needs if I need to actually define an SLO. So with that being said, this is just a gentle reminder of what they are. Let's talk about a couple best practices, right? So if you're not using an internet monitor, I would suggest you enable it and check it out. From there, visualize your VPC flow logs. I don't care how you do it. Visualize them. It could be in, like, we build a new OpenSearch feature integration with CloudWatch logs. That's really cool. It has a new prescriptive dashboard for VPC flow logs. You can do it with contributor insights. VPC flow logs go to S3, so there's a lot of cool stuff you can do there with, like, on top of like Athena and QuickSight, right? You can send it to third-party providers. Or, like, we have a lot of observability partners that do a lot of stuff around observability and flow logging. Like I said, I don't care how you do it. Just do it. It's important. And then, of course, use the network flow monitor agents, right? Like, use these passive listeners. Yeah, so from there, outside of just networking, right, we want to move to that next tier, which is our, we'll call it ELB and web server app and infrastructure, right? And from here, I want to get to, I'm going to ask that another question again, right? Because we're a little bit into the presentation, right? We've been covering some best practices, but just to kind of rehome here, it's a question we ask all the time, right? How do you understand the health of your workload? This comes from AWS well-architected framework. I'm a super fan of well-architected, and specifically this is operational excellence, one of my favorite pillars, maybe behind cost optimization, and it's question 8 if you want to go fact check it. But I'm sure you all believe me. Now, when we think of like how do we understand the health of the workload, right? The first thing that comes down to it is the question I like to get from my customers is like, hey, do you have SLOs? Like, how do you understand your health? Because normally that's what you want to use. And with this, we have Amazon CloudWatch application signals. So what application signals lets us do is give us best practice service operator dashboards. It's giving us those golden application metrics, service level objectives. So this is like the big one, right? Where before in CloudWatch, it was just metrics. And I'll get that last one out for anyone taking pictures. Before it was just metrics, right? And then just alarms. And alarms would always evaluate on the minute, right? So how can I do an SLO that way? It was really difficult. What application signals does is it gives you the ability to create SLOs and SLIs. And then, of course, with the attainment and all the neat stuff that comes along with that. Okay, so how does this work? Like I mentioned, we have the SLO here. So this is, and the reason why I have it outside of app signals is because you can create an SLO on any metric in CloudWatch. It doesn't need to come from app signals. So any metrics you're using today and you want to do an SLO on, you can do that today with app signals. You don't need to do any additional instrumentation, nothing at all. Any metric that exists, custom metric, AWS namespace metric, it's fair game. So we'll feed in these SLO data, traces, metrics, logs, our RUM data, and then of course synthetic data to then build these SLO dashboards, service diagnostics in our service map, right? So think of it as we're feeding a lot of different telemetry into this, yeah, and that's what it is. So it's pretty straightforward, I think. So how does signal collection work here? And what's nice about application signals, it's OpenTelemetry compatible. So the AWS distro for OpenTelemetry is a good way to do it. You can use the CloudWatch agent or even an OTel collector, which is really neat because now with the addition of another new feature that was launched, which is OTLP endpoint support. So X-Ray now has an OpenTelemetry endpoint that you can now actually send OpenTelemetry to directly. I don't think you need to do a conversion from X-Ray to from OLTP to X-Ray. To send it to X-Ray, you can send OpenTelemetry directly to X-Ray, and it'll accept it now. On top of that, you can also then emit that as embedded metric format into CloudWatch logs, which can then send to application signals. So now, any X-Ray trace, you can now actually turn into application signals. What this means is the ability to adopt the service is a lot higher because, or a lot lower, that entry barrier, because now I just have to hit a button. And then now all of my trace spans, everything is now going to CloudWatch logs and application signals. And then I guess another big bonus is it's actually metered at a lower rate too, so it's cheaper to do it that way, which is nice. Now, what's supported in app signals? So we have EC2, AWS Lambda, Amazon Bedrock. So anyone using Bedrock in their applications today? Some Gen AI stuff? Couple? All right, awesome. So yeah, there's a native Bedrock integration, native Kubernetes, EKS on Amazon EKS, and then ECS. Now, outside of that, we want to think of like what language support do we have? And this comes down to Java, Python, .NET, and then Node.js that's in preview mode today. But remember, anything with OpenTelemetry, it is OpenTelemetry compatible, so essentially anything OpenTelemetry is probably fair game. Now, what can we do with app signals? Like I mentioned before, right? We're being able to view RUM and synthetic data. We can view correlated traces. So when we see there's a problem, we can view correlated trace spans for that specific problem or that specific time series. We're then able to define SLOs and SLIs. The important one I mentioned earlier is set burn rate metrics. You can view your dependencies, and then, of course, view your service map. So this is really your prescriptive operator dashboard and a way to actually understand the health of your services. So then when somebody asks that question, how do you understand the health of your workload, health of your service? If we're using app signals, we can answer that pretty easily. Now, some best practices. Like I said, definitely check out the OTel supported via endpoints via X-Ray, and then check out that trace span analytics. We tried it out a couple days ago in a demo account, and I was amazed at what it did. It was pretty cool. Alarm on SLOs, right? Don't alarm on metrics, build SLOs. Alarm on your burn rates. This will let you be proactive about it. Use auto instrumentation. Auto instrumentation is your friend. It makes life a lot easier, and I suggest doing it. You get a lot of bang for your buck with auto instrumentation. And then, of course, just like anything, iterate. You need to do this in a realistic way for your SLOs, and iterating on them is, I would just say that's a general best practice. Now, last but not least, we also want to think of another challenge we kind of see, or another theme, right, is, okay, this works with one, but how do I do it with 10, 20, 30, 40, 50, 100, dozens of applications? Where do I know if I have any gaps in my telemetry? And what we added here today is telemetry config. And this gives us an overview of what signals we have and which ones are actually giving us and where we have gaps. So for example, do we have detailed monitoring enabled? Where do we not, or where do we have logging? Where don't we have logging? So this is a way to be able to look at this from a higher level to see where and if you have any gaps. Now,
right, so yeah, I'll take over. So that's actually cool. That's something that customers always talk about. Like, how do I know whether my EC2 instances are actually sending metrics or not? Am I really collecting my metrics from my EC2 instances? And that telemetry config is a great way for you to just take a look at it. Is my coverage good? All right, let's continue the demo. On the same website, there is a bot. And the bot is powered by Generative AI, and so it basically is there to help users. It's asking the users logging in, how can I help you today? They're asking a question about something he wants answer for, the bot is checking, it's kind of doing some evaluation, and suddenly comes back with an error. So you can see that there is probably maybe a network issue, maybe there's an API, the Bedrock agent that it's talking to, maybe that is not working, or something's wrong there, right, in the API. Maybe there's another facade layer that's in front of Bedrock that is not working. Having sensed that, it is the user is trying to here trick the bot into reveal some information that it is not supposed to. This is called a prompt injection attack, where you are trying to extract information that a Gen AI model or maybe a chat bot or whatever is not supposed to tell you. And it quickly came back and said that, sorry, I cannot answer your question. So there are two things that happen here. One, just to recap, there was an error because of which the bot didn't respond to a question. Number two, the bot was able to successfully defend itself against a potential attack, right? That leads us into monitoring APIs. In this case, we take the example of generative AI, assuming that Bedrock is behind it, right? So what are the things that you can do to monitor Gen AI workloads? Before we go too far into it, the way we like to break down is there are different layers here, right? There are three layers in general when it comes to generative AI environments. The underlying infrastructure and the service itself and the application. What do we mean by underlying infrastructure? Well, for many use cases, you might be excited to use one of the large language models, that many of them that we have out of the box in Bedrock. But there are use cases where enterprises don't want to use those models, and they want to build their own model. They want to do model training. They want to fine-tune existing models because this large language model is too big, too expensive to operate maybe. And also they don't want to trust something that was trained on some other data, but because they have data sensitivity situations and they want to train on their own data. So they build their own models. And they also they host their models at runtime, so there's online inference as well, right? So that basically means you have to monitor how your infrastructure that you're using to train these models, build, fine-tune, and for online inference is performing. And that's generally done by excuse me, GPU-based instances, like NVIDIA GPU-based instances. And if you do that on, let's say, on EKS, we have a CloudWatch Container Insights that supports monitoring from GPU-based instances using DGCM metrics. And you can also use Trainium and Amazon Trainium, AWS Trainium and Inferentia instances. And with neuron containers, you can actually export that as well. But if your model training is really sophisticated and it's distributed across different nodes in a large scale, then there are multiple nodes involved and there's network involved, and there's EFA, Elastic Fabric Adapter Metrics. And all of that is automatically sort of collected in CloudWatch Container Insights, for example, and it's made available there. That can be done in EC2 and other environments as well. Right? Then at the next level is the Gen AI service you're talking about. Bedrock. Bedrock vends a lot of metrics and logs into CloudWatch automatically. Right? We strongly suggest making use of that. Then you have application workloads, like Bobby just suggested about, we talked about application signals. Just turning on application signals is enough for you to collect metrics, logs, and traces from your environment. Now, it's all about putting all this data together and making sense out of that.
Nice. So a couple of key SLOs for Gen AI monitoring, right? I'm going to cover these a little bit quicker, but we're looking at model invocation latency, right? Latency, how quick it takes to run, model performance, how well is it performing, specifically when we look at like token usage and cost. So for example, like we think like a lot of different Gen AI tools are normally billing on token usage, so that's something that's important to track. Infrastructure capacity, obviously that one's kind of like a no-brainer. And then the bottom ones here, right? Data security and integrity, and then content quality and relevance, right? So we need to make sure we're giving quality and relevant answers to our prompts. And then of course the last one, model performance comparison. So especially something like Bedrock where you're able to choose many different models and then set different parameters on those models, that gives you the ability to be pretty selective in what you're getting, and then that can also pay off pretty well in terms of model performance. Getting the right model for the right job can actually be quite a cost saver.
All right, so you have to pay attention to the signals from this environment. So the model invocation signals were like Bedrock the model runtime metrics or the model invocation metrics, where it tells you how long it takes for a model to be invoked and to respond and so on. That's important. That's model performance metrics that is available out of the box. Then Bedrock guardrail metrics that actually and in the demo that we saw before, where we talked about the bot that was being able to successfully defend itself from the prompt injection attack, that was through guardrails. Right? There was a guardrail set up in that environment on the agent, and it was able to swiftly, deny the request. And those things are really important for you to to operate a Gen AI environment in a secure fashion. And the Bedrock knowledge base logs, which are really important too. All the customers, when you're building something like this, you want to be able to your model to be sourcing information from your enterprise data, and you might be using RAG or whatever. So that basically means you're constantly updating the knowledge base on a regular basis, because you don't want the knowledge base to be outdated where it supplies kind of wrong information, right? So there is a pipeline that you would typically set up to update the knowledge base on a regular basis. You want to monitor that as well. That is available out of the box too. And then on top of that, the Bedrock agent API calls that are being made, and who's calling, and all of for security and audit purposes, you want to track that as well. So why do we even monitor Bedrock guardrails? Well, excuse me. In any organization, data security is really critical. That when it comes to generative AI workloads, right? For you to avoid, say, like the prompt injection attacks, or even securing your model from any violations that it's making, you want to be able to detect those violations in advance, so you can take action in advance and sort of be in compliant with audit and reporting requirements that you have, right? And that also allows you to take automated remediation actions. Maybe forcefully trigger a knowledge base update, or maybe add more guardrails and or conditions into the guardrail mechanism and so on. So those are all important. That's really important for you to track your guardrail performance and essentially how the environment itself is operating.
So what are a couple key metrics to pay attention to? We're looking at invocation latency, throttles, server errors, client errors, and then invocations intervened. Intervened, obviously, because their guardrails intervened in an invocation because somebody was doing something fishy, maybe, or asking the chatbot maybe to provocative questions. Who knows? But yeah, these are the metrics that we provide and ones that you would want to look at.
All right. So how does it work? Like I mentioned before, Bedrock vents a lot of metrics, with the model performance metrics, knowledge base metrics, and logs, or even guardrail details and signals from guardrails as well. And that is the Gen AI layer, and you have the application or the infrastructure environment from there. Let's say if it's EKS, it would enable application signals or CloudWatch container insights to get the infrastructure and the application level information. All of that information goes into CloudWatch. Pretty straightforward. All of that is there in one place for you to get the context and kind of query and visualize, alert, and so on. Let's continue the demo. Here, the user continues to use the application, and they're trying to select a particular order, a particular kind of product to order, and they are getting an error. They're frustrated now, I guess. Now they're probably going to do a search. They decide to just go search a product. And when they search a product, they're trying to type in for some thing that they want to purchase. And after they essentially click on search button, they get an error. It could be anything, like we discussed before. It could be an API, it could be a net problem, or it could be a network issue. It could be whatever. But it could also be that the database is overwhelmed. Maybe the website was too popular, and there are too many people querying, and the search is not, the database is not indexed properly enough, so it's not able to serve. How do we identify database issues, right? So how do I know that database is the one that is actually causing the problem, right? So in order to do that, you have to monitor the database, but there are challenges.
Yeah, so for example, we want to think of that things like query performance. Query's got to work fast. User and query conflicts, so maybe you have multiple people trying to write. There's row level contention that happens. Capacity limitations, so scaling databases, right, horizontally or vertically, or if we're going to look at a serverless model. Configuration problems, so being able to tune those databases. And then one that I'm a personal fan of, and something we hear a lot, is correlating application issues with database issues, right? A lot of times we hear it's like, it's a problem with database, but then we don't know how our users are impacted, Or if there's a application issue, you don't know necessarily exactly what's wrong in the database. Or let's say vice versa, you know everything that's wrong in the database, but then you don't know necessarily how that's impacting downstream applications, because more often than not, those teams are different teams, and sometimes they don't talk to each other. So what SLOs do we want to look at, right? So there's some key ones here, right? So we have latency, error rate, availability, and throughput, right? So those are like some of our golden metrics, our golden signals, but so I'm assuming we already know what those are. But a couple other ones, right? Data durability and consistency. So how durable is our data, and then what consistency model are we looking at, right? Is this eventually consistent? Are we doing like cross-region writes? Are we doing like a read after write consistency model, like one of my favorite services, S3 does? And then, of course, lastly, scalability, right? So these are different SLOs you'd like to monitor. Now, what types of tools do we have to be able to monitor our databases?
Right. So first of all, there are two kind of signals that you get from databases. One is the signals from the underlying operating system and the infrastructure, and also the other set is the database engine itself and what is happening inside the database itself. There are two types of signals here. So we strongly recommend enabling enhanced monitoring. Right? So when you enable enhanced monitoring, you essentially get a lot of signals from the underlying environment where the database engine itself is hosted on. We're talking about Aurora, RDS here, just to be clear, right? No surprises here, CPU utilization, file, and file, memory, network, and all that stuff that you typically expect. And these are all published into CloudWatch logs automatically and kept for 3 months that you can extend if you want to. And like I mentioned before, once again, if you want to extract additional metrics, we strongly recommend using metric filters or even using this feature called CloudWatch Contributor Insights that allows you to create top-end reports and keep it updated all the time based on log information that you have. Check that out. For database signals, we recommend enabling performance insights. So performance insights allows you to get information from the database, like query information, sessions, transactions, deadlock, and so on. And that gives you detailed insight into your database engine performance itself. And that is available from within the RDS console. You can look at all that information. You can also add that into CloudWatch. And then at that point, you're able to kind of like put all of this data together into one single view. So it's much easier for you to make sense out of.
So a new feature we have today is CloudWatch Database Insights. And what this gives us is a one-click experience. No hassle or maintenance issues, right? So it's fully managed. The idea is it's going to give us a unified view of log, metric, and trace data in one place, database-specific root cause errors, and then dependency mapping between applications and databases. So we solve that problem that, at least personally, I've seen a lot of customers struggle with. And then that other thing we talked about, right, is like it's not just for one, which is easy. It's always easy to do it for one thing. But doing it for like tens, hundreds, thousands of databases, this is what we built it for. And Amaya is going to walk us through a little short demo of what this looks like.
Right, so this feature we launched literally like 2 days ago or something like that. And once you enable it, you actually get a full view of the entire fleet of your Aurora, Postgres, and MySQL databases. And once you do that, let's take a look at what all you get to see, right? So you get the visibility on like how your, like a honeycomb view of like how your instances are. And on the right-hand side, you can see the top 10 instances per DB load and utilization, where the database is actually being used and how much it's being used. And your events from originating from databases, and also a top 10 report based on different parameters such as CPU utilization and others, right? The most exciting thing in this, like Bobby mentioned before, is this part. Not only we are now talking about just databases. We talked about all these different layers that we have and how it is complex and all that, right? So we're doing our part to solve this problem. The way we're doing is, once you enable database insights and you have application signals enabled on your application that is using these databases, you will actually see which specific service is actually making the call to the database, and that is listed within the database insights console. And when you click on it, and that's all like completely deep linked, so you don't have to go write query or find out what service is calling your database or whatever. So once you click on it, it will take you to application signals with that context preserved, right? With application signals, you go there, you can see the performance of that particular service. That includes your RUM information and like synthetics and the SLOs and dependent services and all of that for you. From the database, now we are all of a sudden in the application context. It's not just that. Let's go further. with this, maybe it is an infrastructure problem. Maybe there's no issue in the application layer. In this case, you can see that this application is actually hosted on an EKS cluster on a specific service. So that service is also listed here, which is deep linked. You can simply click on it. That will take you to the Container Insights console, where you can essentially go to take a look at all your pod's performance, your EKS service performance, and all of the details. So starting from database, you can go to the application, you can go to infrastructure. You can actually, I showed you this way, but you can also go this way as well. You can start with an application, you can go to the infrastructure, all of them is deep linked. So you can see that in all this navigation, you really didn't have to write any queries, you didn't have to remember log group names or metrics, or you didn't have to come up with any fancy join queries or whatever. Everything is out of the box, and the CloudWatch is more and more context aware, and it is able to give you that view of where you should go to find a potential issue that you might want to solve. Right? How does it work? Straightforward, just like how we mentioned before. Once we enable database insights from these environments, we collect metrics and logs into CloudWatch. With EKS, you enable app signals or ECS, whatever. All the data is there. Everything is in one single interface. You can query. You can do using CloudWatch Logs Insights to query logs, or you can even use these days, which we launched again like a week ago or so, the ability for you to use SQL or OpenSearch-based PPL query languages that you want to. All right. What are the best practice recommendations? We recommend enabling performance insights and database insights, which go hand in hand, which really leverages and ups the game in terms of like what kind of information that you get out of these environments. Enable enhanced monitoring for operating system level stuff. And we keep hammering on this over and over. Please set alarms on your burn rates, SLI thresholds. Really set SLOs, first of all, to really track where your performance metrics and so on. And also there's one piece of information that not many are fully aware of, that you can actually set alarms on performance insights metrics once you enable performance insights for RDS as well, using dbperf insights. So CloudWatch has a lot of functions like this for others as well, like for contributor insights and other things, where you can actually go set alarms for metrics that are not already published in CloudWatch. All right, so let's put all of these together, Bobby.
Yeah, so I know we covered like quite a bit today, right? Went all the way from the browser all the way to the data store layer. So let's like key in on a few key takeaways, right? And that is, like we said, I don't know if we said it enough, but we'll say it even more, define SLOs. Instrument everything, right? So from every layer, everywhere you're able to instrument, you want to have some sort of instrumentation. Because if you don't have any instrumentation there, you don't have any signals, there's no way you're going to be able to understand the health of that. The next one, right, and this one's key, because even if you instrument everywhere, if you're not using anything for correlation, you just have a bunch of disparate signals. And that's a problem I think a lot of customers struggle with. And how we do it is by leveraging distributed tracing. So why we called out that RUM best practice is enabling X-ray is because it gives you that end-to-end distributed trace. That trace gets passed throughout the entire application, and then we can preserve context that way. Alarm and SLOs, and automate actions and burn rates. And then lastly, iterate. You'll see this anywhere from well-architected. We talk about it all the time, but it is something that I think is understated, right? When we think about observability, it's not just a destination, it's a journey. And you'll see things like, it's like, hey, do you continually do this? Do you occasionally do this? How frequently do you do this? It's something that you want to think of, and then also like partner with like business owners and application teams together of knowing, are the signals we're collecting actually relevant and representative of the workload? I think that's a discussion that doesn't happen enough. So a couple calls to action here. If you want to get hands-on, check out the One Observability Workshop. If you have your AWS account team and you know who they are, or if you don't, find out who they are so you can talk to them. And we'll be happy to be able to set up one of these workshops for you. You can get hands-on, learn all about these features. The best practices site, we linked it a couple times, but there's a huge community of technical field contributors, such as myself, Amaya, and many, many other people that have contributed to this best practices guide that covers much more content than we've been able to cover today. And if you're looking for like training and skill builders, check out the Observability Accelerator and Skill Builder. Now, with that all said, oh wait, I can go back if people still doing pictures. Yeah, okay. All right, cool. Okay, so with that said, we do want to thank you all for your time today. We hope you have a wonderful conference. Thanks for the time. Please fill out the session survey, and then we'll be here up in the front for Q&A, and then once they kick us out of the room, we'll be happy to talk in the hallway. And then last plug, go check out the booth over at the Venetian. We'll try to be there later today to answer questions. So thank you all.
Thank you.